Hello, welcome to a video on percent, sales tax, and discounts. So in this video we are going to start off with just the changing of percents to fractions, decimals to fractions, percents to decimals, all that stuff. And then we're going to use percent to solve problems involving sales tax and discounts, which are typically given as percentages, and then determine percent increase, decrease, and then just some ways that we can make mistakes involving percentages. Alright, the very basics of percents. Percent means parts of 100. Alright, percent means per 100. The cent, think like there's 100 cents, 100 pennies in a dollar. Cents like century, 100 years. So per cent means per 100. And then if we want to start off like with something basic, like expressing a fraction as a percent, you're going to take the numerator divided by the denominator. Remember, a fraction means division. And then once you get that, you're going to multiply that by 100. Right? You'll get a decimal. You multiply that decimal by 100, and then you'll have the percent. So some common percentages like 50% is the same thing as half. Right? So 1 divided by 2 is a half. That's 0.5. If I multiply that by 100, I get 50%. Right? Put a percent sign on the end, so 50%. 3 out of 4. Alright, hit enter, that's 0.75, multiply by 100, or move the decimal 2 places to the right. It's the same thing as multiplying by 100. So 75%. So there's going from a fraction to a percent. Alright, so some another basic examples, 5/8. 5 divided by 8 is 0.625, multiply that by 100. Alright, that moves the decimal 2 places to the right. Alright, and then stick the percent sign on there. So 62.5%. And if I want to make a decimal into a percent, I do the same thing basically, except I don't have to do the division. I'm already in a decimal form. So from right here, it's basically I'm multiplying by 100, but again, it's equivalent to just moving 2 places to the right. So 2 places to the right, and then stick on the percent sign. So 0.47, 2 places to the right, again, that's equivalent to multiplying by 100. Stick on the percent sign, so 47%. Alright, and then finally, if I want to go from a percent to a decimal, same thing, I'm just going to move the decimal point now 2 places to the left and take off the percent sign. So if I have 19%, the decimal point's after the 19, 2 places to the left, I get rid of the percent sign, I get 0.19. Alright, 180, same thing, get rid of the percent sign, 2 places, so 1.8. Alright, so from percent to decimal, drop the percent, go to the left. From decimal to a percent, you move to the right and add on the percent sign. Now when we do percent problems, percent word problems, we use this amount is percent of base. A equals P times B formula. And notice the of is interpreted as multiplication. Many times in percent problems, the of that we see is multiplication. Now, of is a very common word in our language, so it has to be the of that follows the word percent is the one that we translate to multiplication. Okay, so we use this formula to determine sales tax, like the tax equals the tax rate times the amount of things that you purchased, right down here. So tax amount is the tax rate times the item's cost. We use it for a lot of different things. We're going to use it for discounts in a little bit. Tips, like if you're going to tip your waitress at a restaurant, that is a common thing in your tip percentage, like 10%, 15%, 20% is our common tip rates. Alright, sales tax rate 7.5%, and you purchase a bicycle for $894. How much is tax paid, and what's the total cost, including the tax, going to be? So to answer the first part, what tax is paid, we take the $894 and we multiply by the tax rate. Okay, but when we do math, we need to change the percentages to decimals. So notice we went from percent to a decimal, and we get the 6705. If you just multiply that on your calculator, you'll get that number. And then we take that tax and we add it to the original cost before the tax. And there's the total amount that we pay, including the sales tax. Alright, so very common. Another thing, you can go straight to the 90, you can kind of bypass this if you don't need to know the tax amount, if you just want to know what's the total cost, you can also stick a 1 in front of that 0.75. Once you've changed it to a decimal, you can multiply the 894 times, again, instead of 0.075, multiply by 1.075. And that will go directly to the total cost and bypass that taxes paid. But many of these problems in your homework, they're going to do a two-part thing. They'll ask for the sales tax and then ask you what's the total cost. All right. Discounts, very similar, except instead of adding right here, you subtract, because it's a discount. You're taking that amount off of the total price. So the discount amount is the discount rate times the original price, and then we end up subtracting that to get the amount that's actually paid. So an example, this is the original price of the computer. We got 15% off. So the discount amount is going to be 15% of the total price. So we're going to multiply that again, change it to a decimal form, and then we're going to take that 219, the discount, away from the computer's original 1460 price to get the discounted price. Okay, so the discount is taken away to get your sales price, and then remember the tax stuff is added. So we add tax, we subtract discounts. All right. All right. Now, percent change, percent increase, percent decrease. We have to base a percent off of something. So what we base it off of was the original amount, the amount before the change took place. So if a item went up in value, you know, you purchased a home, and over time the home's value went up. The original amount would be what you bought it for, and then the amount of increase was what it's worth now, what you're going to sell it for, minus what you bought it for. So you kind of take the difference, and that's the amount of the increase. Or if it's like a car depreciates, so it's a decrease instead of an increase. And then you always divide by the original amount. So what I bought my car for when it was new, subtract that what I sold it for, that's the decrease, and then I divide it by, again, the original price, the new car price. So we always divide the change, right, for the difference between the current amount and the original amount, but we always divide by the original amount. Okay. Now think about this: if it's an increase, if something went up, the original amount was always less. If something decreased, then the original amount was always the higher of the two. So that's something you can use to kind of help you navigate through these types of problems. All right, but after we do that division, remember this will be a division, it'll end up being a decimal, and we are going to change that decimal to a percent, right, or a fraction. Do the division to get a decimal, and then change it to a percent. So let's look at an example. So in 2000, the world population is approximately 6 billion, and this is the data from the United Nations Family Planning Program. All right, find the percent increase world population from 2000 to 2150, which is over here, using the high projection data. So we're down here at 6 billion up to 30 billion, and then find the percent decrease in world population from 2000 to 2150 using the low projection data. Notice it actually went down. Down to 4 billion from 6 billion. So we're going to take the change, right, from 30 billion down from 6 billion, that's an increase of 24 billion, divided by the original, right, what it was originally, an increase, so it was originally 6 billion. And here we're going to start, the change was 2 billion, and we're going to start from the 6 billion. Okay, it's always from the original. So for part A, the increase was 24 divided by 6, so that's a difference of 24 divided by 6, that's 4. And remember, that's the decimal, even though there's not a decimal in there. Remember, there's always a decimal at the end. Multiply that by 100, slap on a percent sign, and we got 400% increase. Okay, the world population is projected to increase by 400%. Right, and then part B, the amount of the decrease is 2. We don't have to worry about a negative sign because we're calling it a decrease. So we don't have to say that it went down to, like with a negative number, but just the change was 2 units divided by the original being the 6 units. Okay, the original in both cases here was 6 because that was the earlier date amount. Alright, so 2 6 reduces to a third. A third, if you change that to a decimal, you end up with 0.333333333 forever. So this is a case where changing that to a decimal could potentially be problematic. They may want that to be written as a fraction. The way you would do that is just go ahead and multiply it by 100, so times 100, and then this is can be changed to a fraction with on these calculators, math back into a fraction. But what you'll see is I end up with just 100. 1 times 100 is 100 over the 3, and then you would do long division. So 3 goes into 100 33 times with a remainder of 1, all right, and then you put that 1 back over the 33. So basically all I did there was 100 divided by 3, because I got 100 thirds. Remember, in long division that would be a 3 right there, so I'd have a 3. That would be 3 times 3 is 9 minus 1. I bring down the 0. 3 goes into 10 again 3 times. Alright, I get a 9. So the remainder is 1. Alright, so there's the 33. Alright, and then there's the remainder is 1 over 3. So 1/3. So that's where that's coming from. So for these types of fractions that don't have a terminating decimal, a lot of times I want them written as a fraction within the percent, but other times they'll have you round it. So just pay attention to the way it's asking you, okay? But sometimes you will have to put those as a fractional form. All right, here's an abuse of a percent. So John Tesh, when he was on Entertainment Tonight, it's been a while back, he reported that the PBS series The Civil War had an audience increase of 13% versus the usual 4% audience. So he says that was an increase of more than 300%. So did he report that correctly? Well, 13 minus 4 is 9, and 9 divided by 4 is 2.25, right? 2.25 as a percent, move that 2 places to the right, you get 225. Slap on the percent sign, we got 225%. So that's not more than 300. More than 300%. So what did John Tesh do? He incorrectly said 13 divided by 4 is 3.25. Right? So it's 3.25 times as much, but it is not an increase of more than 300%. It's 325 times the normal amount, but the increase itself is only 9, not 13. The increase was 9, so the increase was 225%. So it's you got to be careful with the wording when you're talking about percentages and increase and decrease. Right? It's the change over the original amount, not the new amount over the original amount. That's something completely different. You're not talking about percent increase or decrease. So you got to be careful if you're going to say that phrase, that you're actually talking about the gap between the two numbers and not just the two individual numbers themselves in like a ratio form.